All right. Well, good afternoon. My name's Jim Stewart. I'm the Director of Registration here at NERC. It really is my pleasure to welcome you to this webinar. This is the second webinar we've had related to developments regarding IBRs and Category 2 GOs and GOPs. And so I appreciate you hanging in there with us and attending this one as well. We believe that this call is going to be informative and will be of great use to you. So it really is, the purpose is to do an extensive review of this new practice guide. The practice guide was developed as a reference document really for the regional entities to conduct the work of registration. It also serves as an aid for industry to improve their understanding or your understanding on how the various configurations of IBRs might be evaluated with respect to registration. The practice guide was published early last month after review by and input from the CCC members and ERO staff. We're not planning, that's kind of what we are planning to do. We are not planning to discuss reliability standards related to IBRs or applicability during today's webinar. We're also not planning to address in any detail the schedule for actual registration of IBRs. As I mentioned before, we've muted all phones and asked that you use the Slido application to submit your questions. I want to acknowledge Tiffany Washington from NERC, who's helped with the webinar, continues to help with the webinar, and who you just heard from. In addition, Pete Heydrich, Principal Advisor from CERC, and Steve Massey, Principal Engineer at NERC, are also assisting with the webinar. We'll hear from Steve next. Again, thanks for joining us today.
All right, good afternoon. My name is Steve Massey. As Jim mentioned, I'm a principal engineer in the registration group here at NERC. I want to start the discussion today by giving an overview of the IBR registration initiative milestones and the associated work plan and its current status. Okay, next slide, please. As I'm sure everyone is aware at this point, NERC received an order from FERC in November of 2022 to develop a work plan to register owners and operators of IBR resources that are not required to register under the bulk electric system definition or the BES definition because the nameplate capacity and connection voltage for some IBR plants do not meet the BES criteria. However, some owners of IBR resources are already registered with NERC. For example, owners and operators of IBR resources that exceed the threshold of the BES definition inclusion I-4 that have an aggregate nameplate capacity of greater than 75 MVA and are connected at a voltage greater than 100 kV. And these are your large wind farms, solar PV arrays, battery storage, and hybrids. But due to the changing resource mix and why we're all here today, many new IBRs have connected to the bulk power system that are below the BES inclusion I-4 criteria. As a result of that, FERC directed NERC and established milestones for us to modify the registration process to include these new non-BES IBRs by May of 2024, to identify the owners and operators of these resources by May of 2025, excuse me, and to register them by May of 2026. We're also required to submit work plan updates every 90 days. Next slide, please. As part of the work plan development, the milestones are referred to as phases. So phase 1, 2, 2, and 3 is shown here. Phase 1 is already completed and includes revisions to the NERC Rules of Procedure, or ROP, and registry criteria. I want to review these changes in the next couple of slides. Phase 2 is the identification phase, and we're in the middle of that process right now. Phase 3 is the registration phase, and that kicks off later this year. Next slide, please. Okay. As part of phase 1, NERC revised the registration criteria for the generator owner and generator operator functions by adding a new category to each of the definitions to account for the non-BES IBRs. These changes are located in ROP Appendix 5B, Statement of Compliance Registry Criteria, and correspondingly in Appendix 2, Definitions Used in the ROP. These changes were approved by the NERC Board of Trustees in February of 2024 and by FERC on June 27th, 2024. Next slide, please. Okay, on this slide, this is the revised generator owner definition that's in the NERC registry criteria. The first part of the definition, labeled as Part 1, is unchanged from before, except for the addition of the Category 1 GO in parentheses. In this part, it's for the entity that owns and maintains generation facilities, facilities with a capital F, and that's important because it refers to the NERC glossary and ultimately the BES definition. So Category 1 resources are BES resources. And this includes all types of resources, whether it's conventional synchronous generators and IBRs. But the second part is the new criteria that was added, and that's for entities that own and maintain non-BES IBRs that either have or contribute to an aggregate nameplate capacity of greater than or equal to 20 MVA, connected through a system designed for delivering that capacity to a common point of connection at 60 kV or above. These entities are Category 2 GOs, and Part 2 is only applicable to IBRs. There will be many examples later in the webinar with different configurations that Pete is going to go over, and we'll go through a lot of different scenarios later in the webinar. Next slide, please. On this slide is the revised generator operator definition in the registry criteria. As you can see, it's the same approach that was taken here as with the GO definition. The first part is unchanged except for the GO Category 1 GOP in parentheses, and again refers to the entity that operates BES generation facilities. The second part uses identical language as the GO Category 2 definition and refers to the entity that operates the Category 2 IBR. Next slide, please. Okay, so this gives us an update on where we are in phase 2, the identification phase. As I mentioned earlier, we're in the middle of this whole process right now. This past summer, a request for information was sent to existing registered balancing authorities and transmission owners to help identify the Category 2 GO and GOP candidates and that are either currently in service or expected to be in service by May of 2026. The RFI process was completed on May 20 of 2024. The chart under the second bullet shows the results of the effort so far, detailing that the total number of plants and MVA capacity by region that have been identified. You can see it's a pretty large number. We're up to 863 plants that have been identified so far for over 38,000 MVA, which is quite a large number. I also want to mention that this chart was included in the latest 90-day work plan update that was submitted to FERC on February 5th, 2025. But it's also, as of that date, so it's subject to further change as we go forward. Next slide, please. As I stated, I want to also mention that we have a request for information process that is ongoing. That is being sent to the Category 2 GO candidates. This effort started in December of 2024 and is ongoing. All of the regional entities are using a common RFI format and consistent process for collecting data. You can see that shown on the screen here. The data request is focusing on verifying specific information to facilitate registration assessments and includes things like single line diagrams, generator interconnection agreements, generator operator agreements, and in some cases, third-party agreements, and possibly other data as needed. Next slide, please. We're also using what's called the GO-GOP asset verification form, which is a spreadsheet. This form has been in use for some time with BES generators or Category 1 GO, so you may have seen it before. But a new tab was created specifically for Category 2 resources, and that's under tab 4B. Some of the information collected on the form includes, specific entity information, such as the entity name, the NCR ID if it's an existing entity, commercial operations date, specific information about the facility, plant location and size, fuel type, things along those lines, voltage connection, interconnecting substation, things like that. And then as well as functional relationships, things like who is, the reliability coordinator, who's the balancing authority, things like that. So next slide, please. Okay, this is my last slide. So this shows the regional entity map. Just want to put this in here just to highlight that the registration process begins with the regional entities. That's really important to keep in mind. The 6 regional entities are shown here from east to west. NPCC, Reliability First. We have CERC, MRO, Texas RE, and WEC. So this map shows their approximate geographic locations and contact email addresses for their respective registration departments. So with that said, next up is Pete Heydrich from CERC, who is very instrumental in helping develop this practice guide and a lot of the different scenarios that he's going to go over. And so without any further ado, I'll pass it over to Pete.
Thank you, Steve, and welcome everyone to the webinar. My name is Pete Heydrich, Principal Advisor of Registration and Certification at CERC. Next slide, please, Tiffany. So a quick review on what practice guides actually are. They're utilized by the ERO enterprise and are intended to promote the consistent application of the subject matter across the ERO, which includes NERC and the regional entities. This practice guide addresses the specific application of the registry criteria associated with generator owners and generator operators, and specifically the revised registry criteria associated with the Generator 2 facilities. Hopefully everybody is going to have the opportunity to download this presentation, because that second bullet on the page here is a link. It is active and it'll direct you to the location of the practice guide on the NERC website. Next slide, Tiffany. Thank you. So the practice guide is divided into essentially 3 areas. First, the registry criteria for the Category 2 generator owners and operators, which Steve just covered a few minutes ago in his part of the presentation. The second piece delves into our principles of application, which includes a review of the processes used by the ERO currently to classify facilities and identify candidates for registration. And then finally, third, the single line diagrams depicting various IBR configurations, including solar, battery energy storage, and wind. Also a review of the ownership principles and aggregation principles are included in the one-line diagrams. And then finally, examples of hybrid facilities that include both synchronous generation together with inverter-based resources. Next slide, please, Tiffany. So the first step, typically always in regards to facilities in the evaluation process, is to make a determination on whether the facilities are classified as bulk electric system or BES. This is accomplished by applying the criteria in the BES reference document and another CMEP practice guide that we have developed over the years that addresses the application of the BES definition specifically to battery energy storage systems and hybrid resources. If the facilities fall below the thresholds for classification of BES facilities, then the Category 2 GO and GOP criteria is applied to those facilities. This application is very similar to applying the BES definition inclusion I-4 for dispersed power producing resources, with a few exceptions. With the Category 2 criteria, we have a lower aggregate nameplate capacity threshold of greater than or equal to 20 NVA and a lower connection voltage threshold of greater than or equal to 60 kV. And Category 2 criteria is limited to IBRs, where I-4 dispersed power producing resources can include, but is not limited to, solar, geothermal, energy storage, flywheels, wind, microturbines, and fuel cells. And in all honesty, any further technology that gets developed from a generation resource perspective could potentially be captured under I-4. Since Category 2 criteria is limited to the IBRs, hybrid resource scenarios where we have combinations of non-BES solar, battery energy storage, and/or wind do not include synchronous resources in that aggregation. Next slide, Tiffany. Thank you. Key points to remember when applying the Category 2 criteria is that non-BS IBRs are connected at a common point of connection at 60 kV and above. They start change from the 100 kV threshold that's associated with the BES definition. Next, aggregate nameplate capacity is the apparent power rating in NVA and is calculated using the apparent power rating of the individual inverters. This is key when calculating that aggregate nameplate capacity for meeting the thresholds within the registration criteria. Operational modes of the facility or limitations associated with limiting components at the facility or restrictions on the capacity provided at the delivery point are not considered in this calculation. Reactive resources, whether being static or dynamic devices, are not included in this aggregation of the nameplate capacity calculation either. Ownership of the facility is not considered when applying the Category 2 criteria. The entire facility is evaluated, and once the facility is classified as a Category 2 facility, then it will be determined who, if there are multiple owners, will be identified as candidates for registration. Next slide, please, Tiffany. So a little bit more on NERC registration considerations. And essentially, if the owners of the resources are identified as candidates for registration, each owner will be registered per the NERC rules of procedure for the generator owner Category 2 function. Now, with that being said, the owners can establish operating agreements or compliance agreements with the other owners and designate a single owner to register on their behalf, but that would constitute a joint registration organization, which not necessarily complicates the registration, but does formally document the fact that that single generator owner will be taking on those responsibilities. Likewise, the operator of the facility is required to register for the generator operator Category 2 function. Next slide, Tiffany. Thank you. So moving on to the attachments, which are the single line diagrams of the IBR configurations, the color coding associated with the diagrams follows the same coding as the BES reference document and the Hybrid Resources Practice Guide, with a few exceptions. To remain consistent with all of our practice guides and reference documents from a registration perspective, blue indicates that an element is included in the BES. This is not a change, it's consistent with the other documents. Our new color, purple, indicates non-BES IBRs that meet the Category 2 criteria and the associated facilities. Green is taking on a dual role within this reference document or the practice guide. And green indicates that an element is not included in the BES, which I'm sure many of you are familiar with, but also green has taken on the expanded role of identifying when BES IBRs do not meet the Category 2 criteria. Orange, through consistent application here, identifies the point of connection of the generation facility to the interconnected transmission or sub-transmission facilities. And then black indicates elements that are not evaluated based on the GEO Category 2 criteria. And we actually have a specific example that addresses where we don't apply the Category 2 criteria to certain facilities toward the end of the examples. And as a reminder, reactive resources, whether static or dynamic devices, are not included in the generation site's aggregation nameplate, but are on occasion identified on these single line diagrams as capacitors, simply just to simplify the diagram instead of trying to come up with multiple depictions of the various reactive resources. Next slide, Tiffany. Thank you. So hopefully on my screen, I don't know if it's my bandwidth or what, but the diagram's not very clear. It's a little foggy. I trust me, they are very clear in the practice guide if you pull that up and take a look at it, but we'll work our way through these as best that we can. This figure depicts a solar generation resource and substation design with an aggregate capacity of less or of greater than 20 NVA. Oh, I'm sorry. Hang on. I skipped over a diagram in my notes. Let me start over again. So this figure on slide 23 depicts a solar generation resource and substation design with an aggregate nameplate capacity of greater than or equal to 20 NVA. The generation resource consists of 20 inverters individually rated at 2.5 NVA for an aggregate nameplate capacity of 50 NVA, which exceeds the 20 NVA threshold. The common point of connection identified by the orange circle is at a voltage of 69 kV, which exceeds the 60 kV threshold. So identified in purple are the facilities that meet the Category 2 criteria, and as a result, the owners and operators of these are candidates for registration as a Category 2 GO and a Category 2 GOP. Next slide, please, Tiffany. This slide is another depiction of a solar facility and depicts a generation resource and substation design with an aggregate nameplate capacity of less than 20 NVA. The generation resource consists of 6 inverters individually rated at 2.5 NVA for an aggregate nameplate capacity of 15 NVA, which is below the 20 NVA threshold. The common point of connection, again identified by the orange circle, is at a voltage of 69 kV, which exceeds the 60 kV threshold. In this depiction, based on those thresholds, the identified in green are the facilities that do not meet the Category 2 criteria, and as a result, the owners and operator are not candidates for registration as a Category 2 GO and or Category 2 GOP. Next slide, please, Tiffany. Thank you. This is a depiction of a hybrid resource that includes both solar and battery energy storage. And the substation design ends up with an aggregate nameplate capacity of greater than 20 NVA. A hybrid generation resource consists of 10 inverters individually rated at 1.5 NVA, making up the solar component, and 10 inverters individually rated at 1.5 NVA, making up the battery energy storage component, for an aggregate nameplate capacity of 30 NVA, which exceeds the 20 NVA threshold. I do want to point out that we have seen different configurations associated with battery energy storage generating resources, and this diagram specifically depicts battery energy storage as being what we consider to be AC coupled. As a result, the battery energy storage inverters are included in the aggregate nameplate capacity. We'll get on to another example that shows DC coupled, and we'll talk about that in a few minutes. The common point of connection here in this example is identified by the orange circle and is at a voltage of 115 kV, which exceeds the 60 kV threshold. So identified in purple are the facilities that meet the Category 2 criteria, and as a result, the owner and operator are candidates for registration as a Category 2 GO and or GOP. Next slide, please, Tiffany. So this is another example of a solar and battery energy storage hybrid generation resource and substation design consisting, again, of solar and battery energy storage with an aggregate nameplate capacity greater than 20 NVA. The hybrid generation resource consists of 20 individually rated 2.5 NVA inverters for an aggregate nameplate capacity of 50 NVA, which exceeds the 20 NVA threshold. As opposed to the previous diagram, this configuration, the BES generation resources, are depicted as being what we consider to be DC coupled. And as a result, the battery energy storage DC to DC converters are not included in the aggregate nameplate capacity due to the DC coupling with the solar inverter banks. So if the DC to DC converters are connected on the DC side of that inverter, they are not part of the aggregation. Just that DC to AC inverter are included in the aggregation. The common point of connection here is identified again by the orange circle and is at a voltage of 69 kV, which exceeds the 60 kV threshold. Therefore, identified in purple are the facilities that meet the Category 2 criteria, and as a result, the owners and operator are candidates for registration as a Category 2 GO and Category 2 GOP. Next slide, please, Tiffany. Now, this diagram is going to look familiar. We've taken one from one of the previous slides, but we've added a component of identifying individual companies here. So this figure depicts a hybrid generation resource and substation design with multiple owners identified as Company A and Company B, consisting of solar and battery energy storage with an aggregate nameplate capacity of greater than 20 NVA. The hybrid generation resource consists of 10 inverters, individually rated at 1.5 NVA, making up the solar component, and 10 inverters individually rated at 1.5 NVA, making up the battery energy storage component for an aggregate nameplate capacity of 30 NVA, which exceeds the 20 NVA threshold. The common point of connection, again in the orange circle, is at a voltage of 115 kV, which exceeds the 60 kV threshold. So here identified in purple are the facilities that meet the Category 2 criteria. And as a result, the owner of Company A, the solar generation resource, and the owner of Company B, the battery energy storage generation resource, are candidates for registration as Category 2 GOs, and the operator is a candidate for registration as a Category 2 GOP. Next slide, please, Tiffany. Here we move on to a figure that depicts a wind generation resource and substation design with an aggregate capacity of greater than or equal to 20 NVA. The generation resource consists of 40 wind turbine configurations individually rated at 2.5 NVA for an aggregate nameplate capacity of 100 NVA, obviously exceeding the 20 NVA threshold. The common point of connection here, again identified by the orange circle, is at a voltage of 69 kV, which exceeds the 60 kV threshold. Therefore, identified in purple are the facilities that meet the Category 2 criteria, and as a result, the owners and operator are candidates for registration as a Category 2 GO and Category 2 GOP. Next slide, please, Tiffany. Thank you. This figure also depicts a wind generation resource and substation design, but in this case with an aggregate nameplate capacity of less than 20 NVA. Generation resource consists of 6 wind turbine configurations, again individually rated at 2.5 NVA for an aggregate nameplate capacity of 15 NVA, which is below the 20 NVA threshold. The common point of connection here, identified in the orange circle, is at a voltage of 69 kV, which exceeds the 60 kV threshold. Therefore, identified in green are the facilities that do not meet the Category 2 criteria, and as a result, the owner and operator are not candidates for registration as a Category 2 GO and a Category 2 GOP. Next slide, please, Tiffany. So this figure depicts a hybrid resource and substation design consisting of wind and battery energy storage with an aggregate nameplate capacity greater than 20 NVA. The hybrid generation resource consists of 20 wind turbine configurations individually rated at 2.5 NVA, making up the wind component, and 8 inverters individually rated at 2.5 NVA, making up the battery energy storage component for an aggregate nameplate capacity of 70 NVA, exceeding the 20 NVA threshold. The common point of connection here, again identified by the orange circle, is at a voltage of 138 kV, which exceeds the 60 kV threshold. Therefore, identified in purple are the facilities that meet the Category 2 criteria, and as a result, the owners and operator of our candidates for registration as a Category 2 GO and Category 2 GOP. Next slide, please, Tiffany. So this figure depicts a hybrid generation resource and substation design with multiple owners, identified again as Company A and Company B, consisting of wind and battery energy storage with an aggregate nameplate capacity of greater than or equal to 20 NVA. Similar to the previous example with individual companies owning assets within these facilities, we're going to cover this from a wind and battery energy storage perspective. The hybrid generation resource consists of 6 wind turbine configurations, individually rated at 2.5 NVA, making up the wind component, and 4 inverters, individually rated at 2.5 NVA, making up the battery energy storage component, for an aggregate nameplate capacity of 25 NVA, exceeding the 20 NVA threshold. Again, the common point of a connection is identified by the orange circle and is at a voltage of 69 kV, which exceeds the 60 kV threshold. Therefore, identified in purple are the facilities that meet the Category 2 criteria, and as a result, the owner of Company A, the wind generation resource, and the owner of Company B, the battery energy storage generation resource, are candidates for registration as a Category 2 GO, and the operator as a candidate for registration as a Category 2 GOP. Next slide, please, Tiffany. Thank you. Now we move into a number of examples that are actually going to look at synchronous generation and inverter-based resources in a hybrid scenario at a single site. The thought here with these diagrams is that the synchronous generation portion already exists, and owners are only adding the IBR portion to these facilities. So for the most part, our analysis is going to focus on the non-BES IBRs, but we will go through the process of applying, as we reviewed earlier, of applying the BES definition to the facilities, whether it's through inclusion I2 or through the aggregate provision in I2 and I4, and then potentially move on to the Category 2 criteria to apply to the non-BES IBRs. So a little bit more complicated, but if you follow the sequence that we're describing here, you should come to the correct result. So here in this example, this depicts a hybrid generation resource and substation design consisting of synchronous generation and battery energy storage with an aggregate nameplate capacity of less than 75 NVA. The hybrid generation resource consists of 2 synchronous generators individually rated at 25 NVA and 8 inverters individually rated at 2.5 NVA, making up the battery energy storage component for an aggregate nameplate capacity of 70 NVA. Now, the common point of connection here, again identified by the orange circle, is at a voltage of 115 kV. So back to the resources. The first step in evaluating the resources is to apply the BES definition to the facilities. So by application of the BES definition inclusion I2, the 25 NVA synchronous generators with a connection at a voltage of 115 kV are included in the bulk electric system. Further application of the BES definition provisions by application of the aggregate nameplate capacity provision of greater than 75 NVA that's included in inclusion I2 and I4, the 20 NVA battery energy storage component is excluded from the BES because the total facility aggregate nameplate rating is 70 NVA, which is below that 75 NVA threshold. Now, the second step in evaluating this example is to apply the Category 2 criteria to the battery energy storage facilities. And by application of that criteria, the aggregate nameplate rating provision of greater than or equal to 20 NVA with a connection voltage of 115 kV, the 20 NVA battery energy storage component meets the 20 NVA threshold, and therefore the owner and operator of the battery energy storage component are candidates for registration as a Category 2 GO and Category 2 GOP. So, based on this evaluation, identified in blue are the facilities that are classified as BES, and identified in purple are the facilities that meet the Category 2 criteria. And as a result of that, meeting that criteria, the owners and operator of the battery energy storage component are candidates for registration as a Category 2 GO and a Category 2 GOP. Next slide, please, Tiffany. Thank you. This is another example that depicts a hybrid generation resource and substation design consisting of synchronous generation and solar with an aggregate nameplate capacity of less than 75. This hybrid generation resource consists of one synchronous generator rated at 25 NVA and 6 inverters individually rated at 2.5 NVA, making up the solar component for an aggregate nameplate capacity of 40 NVA. The common point of connection here, again identified by the orange circle, is at a voltage of 69 kV. Again, the first step here is, in this example, is to evaluate based on applying the BES definition to the facilities. Therefore, by application of the BES definition, with a connection voltage of 69 kV, the 25 NVA synchronous generator and the 15 NVA solar component are excluded from the bulk electric system. The second step, again, is to apply the Category 2 criteria to the solar facilities. So by application of that criteria, of the aggregate nameplate rating provision of greater than or equal to 20 NVA with a connection voltage of 69 kV, the 15 NVA solar component does not meet the 20 NVA threshold. And therefore, the owner and operator of the solar component are not candidates for registration as a Category 2 GO or a Category 2 GOP. Therefore, identified in green, and this is where we use green for multiple purposes here, green identifies the facilities that are classified as non-BES and also the facilities that do not meet the Category 2 criteria. As a result, the owners and operators are not candidates for registration. Next slide, please, Tiffany. This is another example that depicts a hybrid generation resource and substation design consisting of a synchronous generation and battery energy storage with an aggregate nameplate capacity of less than 75. The hybrid generation resource consists of one synchronous generator rated at 25 NVA and 6 inverters individually rated at 2.5 NVA, making up the battery energy storage component for an aggregate nameplate capacity of 40 NVA. Common point of connection within the orange circle is at a voltage of 138 kV. Again, the first step is to apply the BES definition to the facilities. So by application of inclusion I2, the 25 NVA synchronous generator with a connection at a voltage of 138 kV is included in the bulk electric system. By application of the aggregate nameplate capacity provision of greater than 75, which is part of inclusion I2 and inclusion I4, the 15 NVA battery energy storage component is excluded from the BES. And this is based on the facility aggregate nameplate rating being 40 NVA, which is below the 75 NVA threshold. The next step in evaluating this example is to apply the Category 2 criteria to the battery energy storage facilities. So by application of the Category 2 criteria, aggregate nameplate rating provision of greater than or equal to 20 NVA with a connection at a voltage of 138 kV, the 15 NVA battery energy storage component does not meet the 20 NVA threshold, and therefore the owner and operator of the battery energy storage component are not candidates for registration as a Category 2 GO or Category 2 GOP. So, based on this evaluation, identified in blue are the facilities that are classified as bulk electric system, and the facilities identified in green that do not meet the Category 2 criteria. As a result, the owner and operator are not candidates for registration. Next slide, please, Tiffany. This is our final example of synchronous generation together with an inverter-based resource. And this hybrid generation resource and substation design consists of a synchronous generation and battery energy storage with an aggregate nameplate capacity of less than 75 NVA. The hybrid generation resource consists of one synchronous generator rated at 25 NVA and 10 inverters individually rated at 2.5 NVA, making up the battery energy storage component for an aggregate nameplate capacity of 50 NVA. Again, the common point of connection in the orange circle is at a voltage of 69 kV. First step in this scenario, again, is to apply the BES definition to the facilities. So by application of the definition, with a connection voltage of 69 kV, the 25 NVA synchronous generator and the 25 NVA battery energy storage component are excluded from the bulk electric system. The second step in evaluating this example is to apply the Category 2 criteria to the battery energy storage system facilities. So by application of the Category 2 criteria, aggregate nameplate rating provision of greater than or equal to 20 NVA with a connection voltage of 69 kV, the 25 NVA battery energy storage component exceeds the 20 NVA threshold, and therefore the owner and operator of the battery energy storage component are candidates for registration as a Category 2 GO and Category 2 GOP. So based on the evaluation, identified in green are the facilities that are classified as non-BES, and identified in purple are the facilities that meet the Category 2 criteria. And again, as a result, the owners and operator of the battery energy storage component are candidates for registration as a Category 2 GO and Category 2 GOP. Now we have one more example. Next slide, please, Tiffany. In this diagram was developed to emphasize that generation interconnection facilities connected at less than 60 kV that serve a dual purpose of aggregating generation and serving load do not impact the application of the aggregate nameplate capacity provision in the generator owner and generator operator Category 2 registration criteria. So first off, let's address the solar generation resource on the right-hand side of the diagram. It has an aggregated nameplate capacity of greater than 20 NVA and is connected at a voltage of 69 kV. The solar generation resource consists of 20 inverters individually rated at 20 NVA for an aggregate nameplate capacity of 50 NVA, which exceeds the 20 NVA threshold. Common point of connection here, as we identified by the orange circle, is at a voltage of 69 kV, which exceeds the 60 kV threshold. Therefore, identified in purple are the facilities that meet the Category 2 criteria, and as a result, the owner and operator are candidates for registration as a Category 2 generator owner and a Category 2 generator operator. Now, the black indicates the elements that are not evaluated based on the generator owner and generator operator Category 2 registration criteria. The generation interconnected facilities at less than 60 kV, where in this diagram are depicted at 13.2 kV, serve a dual purpose of aggregating generation and serving load. You can see that the rooftop solar is serving the load at those individual households and potentially is serving load at that 13.2 kV level. In addition to that, we've depicted battery energy storage inverter banks connected at 13.2 that are also there to serve load and are not there to be aggregated and stepped up to the 69 kV level. So the rooftop solar generation resources and the battery energy storage resources are not included in the aggregation of the Category 2 non-BES inverter-based generation resources on the right. So connected at 13.2, not included, based on serving or based on the fact that the interconnection facilities have a dual purpose of aggregating generation and serving load. I'm going to let that sink in for a little bit because I know we're going to have questions. But I also think that it bears repeating. So hopefully this is going to be crystal clear. When generation interconnection facilities that are operated at a voltage of less than 60 kV serve a dual purpose of aggregating generation and serving load, the non-BES inverter-based resource generation resources are not included in the aggregation of the Category 2 non-BES inverter-based generating resource. So with that, that is our last example. Hopefully we're going to have some time here for some question and answers. And at this point, I'd like to turn the presentation back over to Jim Stewart. Thanks, Jim.
Well, thank you, Pete. That's a lot of information and given in a pretty short period of time, and you did that quite succinctly, and thank you for that. As Pete indicated, we've said 2 or 3 times on the webinar, we welcome any questions that you might have. Please use the Slido to submit those questions, and we'll try to get to them, as many of them as we can. Right now we don't have any questions, so maybe Pete, you were able to answer every question that could have been asked.
It never happens, but I guess we'll see.
Tiffany, if you don't mind, would you just put a question in the submit it, and let's make sure that we don't have some technical problem here, just so we can confirm that the Slido is working. Yep, there we go. So it appears to be working well. We'll give this a couple of minutes, and I'll stall a little bit. Certainly we'll try to answer any questions we have, and just remind everybody this is the second of our webinars related to this. Also, this webinar will be posted in the next several days. It'll take us a little while to work through the technical details, but if you registered for the webinar, then you'll get a notification that the materials have been posted, and of course NERC will send out an announcement indicating that the webinar is available. Still don't see any questions. We do have one. All right, Pete. The question is, does load at a station ever figure into the discussion of whether an IBR is considered Category 2?
So the category 2 facilities are connected at 60 kV and above. And so load does not play into that. When you get below 60 kV, that's when load has an influencing factor on not including that generation as being part of the aggregation. But at 60 kV and above, load has no influence on application of the criteria.
All right, thanks, Pete. Tiffany, if you could go to slide 34. The question is, what if the BESS is a generator of the same capacity?
So I'm going to assume that we're talking about the same capacity as the synchronous generator. So synchronous generator being 25 NVA and the battery energy storage being 25 NVA. Under that scenario, the synchronous generator would remain bulk electric system, but the aggregate of this facility would only end up being 50 NVA, which would be below that 75 NVA threshold to be classified as bulk electric system. But the 25 NVA battery energy storage would be above the 20 NVA threshold for category 2. And in that scenario, the battery energy storage would be classified as category 2, and the owner and operators would be candidates for registration as a category 2 GO and category 2 GOP. That scenario would change the color coding on this example to show that the facilities that are indicated in green here would actually be color coded purple.
All right, thank you. Steve, I'm going to ask you a question from the webinar attendees. If you are already a registered GO/GOP, will you also register as a category 2?
Thanks, Jim. Yes, the answer to that is yes. Even though they're all part of the one generator owner function, as I was talking about earlier, there's the category 1 piece and there's the category 2 piece. And those have potentially different effective dates. So if you're an existing generator owner, there's going to be a process that we're still working out the details on, where your GO registration is going to default to a category 1, and then all category 2 owners, whether you're an existing GO or brand new, are going to add the GO category 2 registration. So if you're existing, you're going to add the category 2. If you're brand new, it's going to be a new registration with category 2 and with the effective date as well.
All right, thank you. Pete, this is back to you. All of the example diagrams, except the one showing load being served, depict the common point of connection at a point where the entire facility is connected through a common element, which carries the entire load of the facility. I don't really see that that's a question.
So
Go ahead.
I can address that though, Jim. Thanks. So these depictions are really trying to simplify configurations that we know that exist out there in the industry to provide these examples. Obviously, facts and circumstances associated with all of these facilities need to be taken into consideration. There can be multiple points of connection, but if they're electrically the same and a loss would result in the full facility being removed from the bulk power system, that's where the risk resides, then they would all be included in the category 2 classification. But like I said, reach out to your regions, take your one lines, and actually show those specific configurations, and they can assist with the actual accurate assessment of them and provide you with an accurate determination on what facilities are potentially category 2.
All right, thank you. Steve, this is just for you to note, if you would. While we feel the industry agrees that separate points of connection are excluded, and then the second part of that is an example of such configuration to show a non-applicable facility would be beneficial. So I guess that's just feedback as far as our, as far as a future webinar might be concerned.
Okay.
Pete, here's another question for you. If there are two separate solar plants that are 15 megawatts each that interconnect at the same 115 kV substation, but have two separate interconnections, not aggregated before interconnection points, is that considered two 15 MVA units or one 30 MVA unit?
It's solely going to be determined based on the configuration of that 115 kV substation. So that's another one where the facts and circumstances are going to dictate the outcome of the application of the Category 2 criteria. And having the one-line diagrams is essential to be able to give an accurate answer here, Jim. It's really going to depend on the actual configuration there.
All right. Got another question for you, Pete, regarding figure 14. So Tiffany, if you wouldn't mind going to that. If the battery energy storage system inverter bank results in the export of power to the BPS, can it ever be considered Cat 2 GOGOP if its aggregate nameplate is more than 20 MVA?
At this point, based on our practices and applying the Category 2 criteria to the facilities, they would not be included even if there is backflow up to that 69 kV level. Now, I'm not going to say that in the future, we may have to take considerations there depending on how much generation migrates down to a less than 60 kV level. But today, based on our current application of Category 2, we would not consider that backflow to the 69 kV within our aggregation.
All right, thank you. And it sounds like I need to have a question up so you folks can see that. I'm not sure that we can do that right now on the fly, but we'll see if we can't do that in the future. So we're not going to really get into the standards or compliance matters, but someone has asked the question, if you qualify as a Category 2 GO or GOP facility, does registration include SIP, PRC, and MOD compliance, or is this just registration? It'll really just depend on whether the standard that is written includes, the Category 2 GO and or GOP. So it completely depends on how the standard is written and the applicability. Pete, I think this is probably yours. On the point of interconnect, are we saying that multiple generation items that tie into common transmission lines are considered one facility? What would allow delineation between independent generators that interconnect at a common switchyard?
Well, again, it's going to depend on the configuration of that switchyard and how the facilities are actually interconnected. There's how many different configurations are out there for these substations and switching stations. So it's really going to depend on the facts and circumstances. And to provide, I think, a blanket answer here, Jim, would be irresponsible and push people potentially down a path that they should not be going, and potentially assuming that they would not be included as a Category 2 facility. So again, facts and circumstances absolutely matter here. And I suggest reaching out to your regional entities, the registration group there, with one-line diagrams. Come up with specific examples so the facts and circumstances can be evaluated, and then a good faith determination can be made that's technically justifiable for the Category 2 criteria application.
All right, thank you. There was a question about GADS, and I don't think that any of us are really prepared to speak to GADS. That's not, the three of us work in registration, and while we have some interaction with the GADS team, I don't think we're able to answer that question. So I think we'll do a pass on that. Figure 14 again. Pete, this is what if 2 megawatts of load is connected to the IBR collection bus? Would the IBRs be category 2?
So I'm going to assume that we're talking about the battery or the solar component here that's included and identified in purple as category 2 facilities. It's going to depend on the nature of that load. If that's on-site station service load, then that has absolutely no impact whatsoever. It's really, again, going to depend on the facts and circumstances of that load and what it is actually serving going forward. So again, one-line diagrams and detailed one-line diagrams are crucial to the application of the category 2 criteria, and your regional entity would be more than happy to help with that determination going forward.
Kind of winding down here, Pete. One more question is, actually a couple more. Are there 2 points of connection? Let's start over again. Let's go to slide 36. It looks like you were way ahead of me, Tiffany. Are there 2 points of connection shown on slide 36 or one common point of connection in the slides on the webinar?
So in this depiction, the point of connection that's identified by the orange circle is the point of connection that's really of concern here when applying the category 2 criteria. So that's a single point of connection associated with the solar component of the category 2 facilities. The interconnection point that's at the 69 kV level to the 13.2 kV is a load serving connection point where those facilities are used to aggregate the lower level voltage connected generation resources at 13.2 and collectively serve load. So dual purpose of those facilities. So when applying the category 2 criteria, our common point of connection that we're primarily concerned with is the one in the orange circle associated with the solar component on the right-hand side of the diagram.
Thanks, Pete. Steve, this question's for you. If I have a 25 MVA IBR facility that also serves 10 MVA of load, do I need to register as Cat 2?
Okay. Yeah, I would say maybe. This gets back to the response that Pete had said several times. You know, it really depends on facts and circumstances and interconnection configurations and things like that. So it's tough to answer that without actually seeing the one-line diagrams and configuration. So I would say take that to your regional entity with some one-line diagrams and have the discussion for a determination on that one. And one other thing, Jim, if I could, the question about GADs, I think, had to do with, do I need to register now to get ready for that? Essentially was the question. And I would say, if that was the question, the answer is no, we're not into the registration process yet. If you recall the milestones that I talked about earlier, we're still in that identification milestone, which is phase 2. We haven't entered into phase 3 yet, which is the registration process. So that will occur at the earliest of May of this year through May of 2026. That's the registration window. So we're not quite there yet.
All right. Thanks, Steve. There was a question about compliance dates, and that really depends on the compliance dates that are associated with the standard. The standard, when they get approved, has compliance enforcement dates, and so that we're really not able to answer that anymore on this call because we're really focused on the registration process. But the compliance date is going to depend on the standards as they're written and then the effective date. Another question, Pete, are the DC coupled battery energy storage system assets in scope for registration if they don't count toward aggregation? And someone has noted that's figure 4.
So yes, they are. They're part of the classification as category 2 criteria. Now, whether the reliability standards are going to identify them as applicable facilities for the individual reliability standards, that's up to the standard development process and through the implementation of those standards. But from a classification perspective, they do influence the facilities. They potentially pose a risk, so they are included in the classification as category 2.
All right, thanks, Pete. You're on a roll here. I've got another question for you. If a known to be category 1 facility has phases to the construction and phase 1 qualifies for Cat 2, should we register as Cat 2, then change to Cat 1 later when additional construction occurs?
So when the facilities in phase 1 that are going to be classified as Cat 2 reach their commercial operations date, yes, you're going to be registered as a category 2 generator owner and or category 2 generator operator. As facilities get added, those should also trigger a reevaluation of the registration status for that entity and have to be communicated to your respective regional entity, registration department. As you approach those NVA thresholds and you exceed those, then the registration can shift and reclassify those facilities to category 1 bulk electric system, which would then trigger a change in the registration to be a category 1 GO and GOP versus a category 2 GO and GOP.
All right, thanks, Pete. This one's wordy, but I think it's straightforward. A common example in our switchyards is 4 transmission lines with common bus and ties on the transmission side with independent connections on each generation asset that can be tied to any of the lines out. Our take has historically been these are independent interconnects. Is that changing?
Again, it's going to be the facts and circumstances and the design of that facility. I'm sorry to say that potentially that might have been misclassified in the past. So again, the specific one-line diagrams that are detailed enough to evaluate should be taken back to your regional entity and have them come up with a consensus determination here on the category 2 criteria application associated with those facilities.
All right, thank you. Steve, this one's for you. In the past, entities could stay away from NERC applicability by having a nameplate rating of 74.9 MVA capacity. Could an entity with IBRs up to 74.9 MVA stay away from NERC applicability by stating a dual purpose of serving load of any amount? Also, is there an effort to define a dual purpose?
Okay. Well, first of all, I would hope that the objective is not to build a facility that's just a hair fracture under requirement for registration, but that's beside the point. No, I would say it has to do with the interconnection of facilities and the purpose of those facilities. If the facilities are designed, and the language that's used is a system designed primarily for delivering the capacity. So the facilities that are part of the collector system that are interconnecting the generation, if their sole purpose, the reason they were constructed was to aggregate the generation and deliver it to the bulk power system, then that gets aggregated. Making a statement that that's used for serving load or something is not really applicable. It really has to do with how those facilities are designed and what their interconnection purpose was. The example that Pete gave, and it's on the screen here, you couldn't take a look at this diagram and the purple facilities here and say that those are serving the load of those houses down the stream on the 69 kV. That would not be appropriate because this system in purple here has a common interconnection point with a system that was designed for delivering the capacity to that point. Now, what happens beyond that point is not what we're talking about. If there's That's a separate thing. And that's the point we're trying to make. Even if there's generation connected down there, if it's on the distribution system, that's evaluated separately, and it can't be like subtracted out, if you will, from this battery system or this solar system that's shown here. So hopefully that answers the question. But again, gets back to the point that I think we've made over and over again, that if there's any question about it, talk to your regional entity, have an open conversation about the ratings and the one lines and the interconnection and how to apply the practice guide, because that's really the key point here. There's a lot of help out there to make these determinations through the regional entities, and I would highly encourage you to take advantage of that.
If I might just add one other thing to that, there's a real effort to be consistent across the ERO as well, so that the answer you get in discussing with one region would be the same answer you'd get with regard to another one. All right, that was an entertaining set of questions. Thanks for the engagement. Really appreciate that. Especially thank Pete and Steve for ponying up to the answer bar and providing a response to these questions. Really do appreciate that. As I said earlier, the recorded webinar will be posted in the next several days. If you registered for the webinar, of course, you'll be notified. And then, of course, there will just be a notification on the NERC website indicating that the slides have been posted. So with that, we'll bring the call to a close. Thanks, everybody, for your participation, and have a good afternoon.